Good morning, everyone. Today I'll be presenting an evaluation of various methods of film dosimetry for SRS-QA. A shorter title for my talk could be paraphrased from the words of Hamlet: to XD or not to XD? That is the question. I have no conflicts or anything else to disclose. Film is an ideal dosimeter for SRS due to its very high spatial resolution. And for ACDS Level 3 SRS audits, which are currently in field trial, film metrics are primarily used for scoring the audit. EBT3 and EBT-XD would be the two main film types predominantly being used for SRS-QA. And most recently, XD has come onto the market, specifically being earmarked by the manufacturer as being suitable for SRS and SABRE, having a dose range up to 40 gray in comparison to EBT3, where the recommended dose range is up to 10 gray. In addition to the choice of film type, there is also a choice of how to calculate the net optical density for a given exposure, and specifically where to derive the background optical density. The first of the three methods that will be discussed in this talk is the stock-to-stock method. And so for this method, the background optical density can come from a region of interest on any film or films from the same film lot as the irradiated film of interest. For the film-to-film method, the background optical density is taken from the same film prior to irradiation. And for the pixel-to-pixel method, the net optical density is calculated on a pixel-to-pixel basis by co-registering a pre-scan with the irradiated film. So really the overall aim and question addressed by this talk is: what is the impact of film type and net optical density method on SRS dosimetry? All of the data that will be presented in this talk came from 3 different film lots per film type. And all of these scans were performed using a scanning template in order to reproduce the position of any pre-scan and post-scan on the central axis of the scanner bed. All the calibration curves were generated using 12 calibration films ranging from 0 gray to 36 gray. And while we're analysing these 3 different net optical density methods for the experimental films, all of the calibration films are processed using a film-to-film net optical density method. Finally, we used some in-house developed programs, first of all Daffodil to convert our scan to a dose map, and Marigold to analyse our dose maps against the provided RT dose file for each plan. There were 4 layers of experiments that were conducted for this study. The first is a comparison between a film measured and pharma measured dose in reference conditions, and this is performed by delivering known doses to a set of check films, doses ranging between 5 and 30 gray. For the remaining experiments, clinical SRS plans were delivered to the Max HD Phantom, and this Phantom allows us to sandwich together EBT3 and XD films, so all of the irradiations are performed with the 2 film types in parallel. We're also able to abut a microDiamond detector to the film plane. So the second experiment compared the film measured doses to the microDiamond measured dose. The third experiment compared the film measured dose to the RT plan dose, and the final experiment is a head-to-head comparison between the EBT3 and XD measured doses. For the film versus pharma experiment, we used a check film scale factor to evaluate the agreement between the control dose and the film dose. And this graph here plots the results from 54 different pairs of EBT3 and XD check films irradiated in 17 independent experiments. And while you can see that the mean scale factor is about 1 across all the different conditions, the standard deviations or the noise of the dosimetry did vary. For EBT3, there was no notable difference between the stock-to-stock method and the film-to-film method. And you can see for the green channel on the RGB average, the standard deviations are around about 2.5 to 3%. And this was very similar to EBT-XD when processed using a film-to-film method. What's clear from this slide, though, is that the stock-to-stock method resulted in much noisier dosimetry for XD, especially for the blue channel, where that standard deviation was about 6%. An immediate question which arises from this graph on the left is whether the noise in the dosimetry relates to the dose that's delivered to the check films. And so on this graph on the right, we present the absolute difference from agreement between the RGB film dose and the control dose. And we stratified that at this 10 gray threshold, which is the recommended upper limit for EBT3. And what you can see is that for both of the film types and the netOD methods, there was no difference in the absolute difference from agreement between the check films and the known dose at that 10 gray threshold. Breaking down the film versus pharma results at a channel-specific level, you can see that for XD, the film-to-film method performed significantly better compared to the stock-to-stock method, whereas for EBT3 versus XD, there was no significant difference in the results for the different channels except for the red channel, which performed slightly worse for EBT3. There was a very similar trend in the results of the film versus microDiamond experiment using the clinical SRS plans. You can see that for XD, the stock-to-stock method performed significantly worse than the film-to-film method for the blue channel. However, for all other comparisons between EBT3 and XD, there was no significant difference in the results. Moving now to the film versus plan comparison, looking at the distribution of gamma pass rates, you can see that the results for EBT3 were very similar to EBT-XD, with the exception of XD when processed using a stock-to-stock method, where there were a few additional outliers and a greater spread of results. Again, for the distance to agreement metrics, there were very similar results between EBT3 and EBT-XD. The final comparison made in this study was between sandwiched EBT3 and XD films irradiated in the head phantom. And the metric that was used for this comparison was the average per pixel difference between the two film types in the region of the film receiving greater than 10 gray and the region of the film receiving less than 10 gray. When using a film-to-film netOD method, the mean difference between EBT3 and XD was at most 2% in the less than 10 gray region, and for the greater than 10 gray region, the mean difference was at most 4% with a standard deviation of 2%. When processing using a stock-to-stock method, the spread of results is larger for both of these regions. The example on the right here shows a large offset between XD and EBT3, which is resolved when you use the film-to-film method for processing both sets of film. And in this case, it is the XD rather than EBT film which shows the largest difference in results between the stock-to-stock and film-to-film method. Finally, I'd like to mention the pixel-to-pixel net optical density method. And here you can see an example of a dose map that has been produced using the pixel-to-pixel method versus the film-to-film method. And as you can see, there's virtually no difference between those two methods across a range of different audit films. What the pixel-to-pixel method is capable of doing is reducing artifact which is on both the pre-scan and the post-scan. However, what it cannot get rid of is artifact that's introduced either on the pre-scan or the post-scan. And in fact, if there's any difference between the pre-scan and the post-scan, it will show up as a difference in the overall dosimetry. To summarize now, there are theoretical advantages of XD over EBT3 presented in the literature. However, there's very limited head-to-head data for real clinical SRS applications. The main findings of this study were that EBT3 performs very similarly to XD for SRS dosimetry. And furthermore, the stock-to-stock method, which is the simplest method of calculating net optical density, is appropriate for EBT3. In comparison, to reduce the noise of XD dosimetry, a film-to-film netOD method should be used. To conclude now, the ACDS uses EBT3 for both SABRE and SRS audits, and a stock-to-stock method for processing our audit films is used. Our findings also support triple channel dosimetry or green channel only for high dose applications such as SRS. These are my references, and I'd like to thank you for your attention and would welcome any questions.